Hello. In this session, we shall first discuss the addition of matrices. When we want to add two or more matrices, the only important condition is that the matrices must be of same order. Once we make sure that the matrices are of same order, we proceed by adding element by element, that is by the corresponding entry of each matrix together. Let's look at this. Suppose this is a matrix A and this is a matrix B. Order of this matrix is 2 by 2 and order of matrix B is also 2 by 2. Now because these two matrices are of same order, I can proceed with addition. And when we add, we will be adding the corresponding entries. The first element of matrix A and the first element of matrix B are added to get the first element of the resulting matrix. Similarly, the second element of matrix A is added to the second element of matrix B to get the second element of the resulting matrix. And yes, of course, the resulting matrix is also of the same order. Let's look at this. This is a matrix of order 3 by 2. This is also a matrix of order 3 by 2. Because these two matrices are of same order, we can proceed with addition. And when we add, we will be adding the corresponding entries. The first elements in the first matrix and the first element in the second matrix are added to get the first element in the resulting matrix. Similarly, B1 plus D1 is added to get the second entry. So is the case with all the other entries. Or if I want to generalize this, if A is a matrix with elements or the entries as Aij and A is a matrix of order m by n and B is also of the matrix m by n with the entries as Bij, then if I add A plus B, it must be Aij plus Bij and the resulting matrix is also of the same order m by n. Let's quickly look at these examples. I have two matrices. Order of this matrix is 3 by 2. Order of this matrix is also 3 by 2. So we can proceed with addition, and when we add, we will be adding the corresponding entries. The first element 2 and the first element 5 are added to get 7 as the first element in the resulting matrix. Similarly, 4 plus 1 is 5. 0 plus negative 9 is negative 9, 6 plus 3 is 9, minus 1 plus 0 is minus 1, minus 2 plus minus 3 is minus 5. So this is the resulting matrix with the same order 3 by 2. Let's look at this. This is a matrix of order 3 by 3. This is also a matrix of order 3 by 3. Now because the orders of these two matrices are same, we can add them. And when we want to add them, we will be adding the corresponding entries. 1 plus minus 1, that's 0. 3 plus 3, that is 6. 7 plus 4 is 11. Similarly, 2 plus minus 5 is minus 3, 0 plus minus 8 is minus 8, 1 plus 12 is 13, 4 plus minus 5 is minus 1, minus 5 plus 4 is also minus 1, minus 2 minus 6 is minus 8. This is the resulting matrix, and order of this matrix is also 3 by 3. Let's now proceed with the properties of matrix addition. Matrix addition is commutative. What is commutative? If I have two matrices A and B of the same order, then A plus B and B plus A are same, right? So is the case with associative property. Matrix addition is associative as well. What is associative? That is A plus B plus C is same as A plus B plus C, where A, B and C are matrices of same order. If A is a matrix of order m by n and 0 is a 0 matrix of the same order m by n, then A plus 0 is equal to 0 plus A is equal to A. Now 0 matrix means every element of that matrix is 0, right? So if I want to add a matrix A with the 0 matrix, I get the same resulting matrix. So this is called additive identity. This matrix or this 0 matrix is called additive identity in the matrix addition. And if A is Aij, that is a matrix with m by n order and the elements of the form Aij, then there will definitely exist a negative of this matrix as negative A is equal to negative of Aij, such that when I add these two, I get the additive identity as 0 matrix or the null matrix. So this negative A is called additive inverse of A. Let's now look at subtraction of matrices. If A and B are two matrices of same order, we can subtract the two matrices by subtracting the corresponding elements. Let's look at this. If I call this as matrix A and I call this as matrix B, then this matrix A is of order 2 by 2, matrix B is also of the order 2 by 2. And when we want to subtract A and B, we subtract the corresponding entries. The first element of the matrix A minus the first element of the matrix B will be the first element of the resulting matrix. The resulting matrix will also be of the same order. Now here B1 is the second element, D1 is the second element here. When we subtract, B1 minus D1 will be the second element in the resulting matrix. So is the case with the third element A2 minus C2, and then it will be B2 minus D2 as the fourth element. Or if we want to generalize this, we can say that if A is a matrix with the elements as Aij and B is a matrix with the elements as Bij, and both A and B are of the same order m by n, then if we subtract, A minus B will be Aij minus Bij, and this matrix A minus B will also be of the same order m by n. Let's look at the simple example. So if I want to subtract these two, first can we subtract them? Order of this matrix is 3 by 3, order of this matrix is also 3 by 3, 3 rows 3 columns. So yes, we can proceed with subtraction. And how can we subtract? We subtract the entries, corresponding entries. First element of this matrix minus the first element of this matrix. 7 minus 5 is 2. Similarly, 3 minus of minus 6 is 3 plus 6, that is 9. 6 minus of minus 3 is 6 plus 3, this is also 9. Similarly, 2 minus 0 is 2, 0 minus 1 is minus 1, minus 8 minus 4 is minus 12. 1 minus 1 is 0, minus 4 minus of minus 4 is minus 4 plus 4, which is again 0, and minus 2 minus 5 is minus 7. This matrix is also of the order 3 by 3.